Bismillahirrahmanirrahim. Welcome to Easy Learn. This is the episode 18 of Introduction to Electronics Season 4. As you know, we are just discussing the episode and started the second portion of the Introduction to Electronics Season 4, where we are discussing the applications regarding to the what we discussed in the first portion, like magnets, electromagnetism, and so on. So we are going to discuss alternator. It is related to the previous episodes where we discussed DC motor, direct current, electric motor, direct current generator, and alternator is basically the same thing. First of all, let's recap to the previous section. DC motor is basically a device which converts our electrical energy into rotational mechanical energy, while the DC generator is a device which converts our rotational mechanical energy into electrical energy. Basically the process is same, but if we provide one thing, the other can be obtained using this device. Alternator process is exactly same as the DC generator. It is basically alternator is alternating current generator, so it is AC generator. In other words, we can say alternator as a AC generator, and the AC generator is almost same. Its working is same as the DC generator, but a little bit different, and we are going to discuss this in how many ways it is different and how much we can elaborate how many differences and how the working principle differs from each other and at what stage. So let's starting from the basics. That suppose this is a front view of the coil. This is the coil actually, and we are going to discuss the front view. This is the north and suppose south pole here, and magnetic field lines. But this is the side view. I'm discussing the top view, where only this back side of the coil is just can be we can only view this is visible portion only. So this side view, okay, when our magnetic field is perpendicular to the paper, means from left toward right, and the coil is placed vertically at the 90 degree, exactly vertically, so that the normal surface of the coil is this is the normal to the surface of the coil, and the angle between the normal to the surface of the coil at this stage, for example, we call this is a position 1. At position 1, the normal to the surface of the coil is this what I highlighted. This is the normal to the surface, means 90 degree to the surface. That's why I call this is the normal to the surface, what I draw this line. The angle between the normal to the surface and the magnetic field is 0 right now, is 0, because this is all also in the same direction, and the angle is exactly 0. And at this point, when the angle is 0, the formula for the magnetic flux becomes maximum, because formula is flux is equals to BA cos phi. And when we are discussing that, the magnetic field lines is exactly making an angle of the 0 degree with this normal to the surface of the coil. This means that the theta is equals to 0. So cos theta is equals to 0, cos 0 is equals to 1, and cos shows its maximum value of the 1 at 0 degrees. It means that we can obtain the maximum flux generate in the coil at this position when it is vertically or any position. Right now we're just discussing this case and it is placed vertically. In other words, for the general case, we can just say that when it makes the angle of 0 degree from the normal to the surface of the coil and with the magnetic field. But right now I can say at position 1 it has the maximum coil. For the sake of understanding, just say for the mentioning other, for just differentiation of this position with the other, I'm just highlighting it. For example, plus minus signs, I just draw it here. This is the second position, P2 suppose, and after that I just take another position. I'm not discussing the other position, for example at this position and then at this position and this, just discussing the next, that by shifting it at 90 degree, and now it is placed exactly horizontal. And now when in this position, the normal to the surface of this is this line is the normal to the surface, because it makes angle of 90 degree with the coil surface. Okay, angle between normal to the surface of the coil at this stage is makes the angle of 90 degree with the magnetic field. What does it means? It means that when it makes the angle of the 90 degree, cos becomes 90, because theta is 90, so cos 90 0. So when cos multiplied with BA, everything becomes 0, because cos value is 0 multiplied whatever the terms, it overall becomes 0. So phi at this stage magnetic flux becomes 0, and this is the minimum magnetic flux is 0, and it is obtained when the coil is placed exactly in the direction of the magnetic field, so that the normal to the surface of the coil makes the angle of the 90 degree with the magnetic field. Anyway, right now the plus minus cases are this plus minus, means just want to point out that this position, sorry, I just draw wrong side. This is the plus, because it changes right now. I'm just moving in the clockwise pattern. I'm trying to elaborate the clockwise pattern. Okay, next, first it was at this position, it is again in the same position. In this sense we can say the angle is same, because it is again in the vertical position. But now what happens, the situation is, it makes the angle again with the normal to the surface of 0 degree, so that the maximum flux can be obtained. So cos 0 is equals to 1, so BA overall. But right now there is a negative sign. The negative sign indicates that the plus sign is here and negative. Before, in the first case, in the first position, the positive side is on the upside. This coil has a mark. For example, I just want to, for the sake of just elaboration and differentiation, for example, this coil has a mark, green mark. By rotating, this green mark is here, and now the green mark has changed its position towards here. It means that we are rotating our coil in this in the clockwise direction by changing its phase shift. So it means that the coil has changed its position, so it means that the direction is opposite right now to the first one case. If I'm just considering it's this positive, then it means we have to take this one negative, because both are not positive at the same time. This is up to us, this is not a standard. Okay, again now, right, what happens, the dot what we marked for the elaboration from for just the difference with the other positions. This is the position 4, while this was the position 3 previous case. At position 4, it makes again the normal. This is the normal here, downside this time, and it makes again the angle of 90 degree with the coming magnetic fields. It means that, what does it mean? It means that again cos 90 is equals to 0. When it multiplies with other terms BA, it will become 0 too. So it means that the magnetic flux here is 0. So negative 0 or 0 is the same thing. If again we can also mention the negative here because of the opposite direction to the case 2, but negative, of course, it doesn't make any sense because it's already 0. And in the finally in the it completes its cycle in the P5 position 5. It just come back to its again original position, and the magnetic flux is the BA simply. and this is the overall first point. When I take position 1, position 2, it will become 0, position 3 negative BA. This is actually negative BA, as this is positive BA, and it is the maximum case. This is also maximum case. This is not the minimum. Minimum is 0. It is basically just due to the opposite in opposite polarity, means opposite polarity just change. It doesn't mean that this is the lowest value or highest value. These are both the peaks. It is just the upper peak and this is the lower peak, while this is the 0 and the minimum value. Okay, we just take the 5 positions and I just marked here when it is started from BA, then 0, again negative BA, 0, and then again BA. By joining these points that were taken from the previous picture, we can draw this wave, and this looks like a sinusoidal wave. It means that the flux generated through this coil, through this pattern is in this coil is a sinusoidal. No doubt this current generated, the pattern in the DC generator was also the same, but where does the difference matters? It will come in the coming slides. I'm not trying to mention here so that all things gonna be mixed up. Okay, the magnetic flux varies from plus BA to 0 to minus BA. This is what we already discussed. You can read out by yourself this theory. According to the Faraday law, the EMF induced in a coil is equals to negative due to Lenz's law, and changing in the magnetic flux with respect to time. Basically, the more the change in the magnetic flux with respect to time, the more and more is the magnetic flux generated. By the way, mathematically we can write this formula, especially when the frequency include, this formula becomes, especially in this case, alternating case, EMF is equals to MBA, number of terms also here, but I just don't mention here because for the single case it is n is equals to 1. So n, same, B stands is the magnetic field, intensity, A is the area of the coil. This is again the same, magnetic flux. It's basically just opening the magnetic flux formula here. Okay, 2 pi f, what is this? It is basically the complete cycle and the frequency harmonics. 2 pi f, sine theta, actual formula is sine theta, but here the sine theta is the 2 pi ft, and t is the time taken by the completing the cycle, while 2 by f is the again the complete parameter of the harmonics. And this is the beautiful picture, and it just tries to for the further understanding. If anything it was not able to be clear, because what I draw in the previous diagram actually try to draw, but I cannot draw the exact like this. Okay, this is the point P and Q, what I tried to mention in the previous diagram with plus minus. This is the coil that rotates on a fixed axle, and when it tries to complete a cycle like this way, and the side view what we discussed in the previous case were like that, P, Q, and then P here, but I tried to mention they were positive, negative, and then this is the same, and this is what we obtain with the passage of the time, the flux, and the EMF. So here comes something new. You can see that the first coil, the first node and the first end of the coil is connected with the first ring, and this is called slip rings, and these rings are a little bit different. Of course, these rings are used to collect the current out from the circuit, out from the coil to the circuit, towards the circuit, and these rings are used as in the case of the DC generator, but there is a difference. These rings consists of totally round and without a totally conducting surface, without any gap between them as insulating material, and the two two slip rings must be used, two rings, while uh, other is connected with the other end of the coil. Okay, here we are going to discuss the first an example, then we are going to discuss the previous slide again in details. For example, if we are given with the square coil have a dimensions 0.1 the 1 meter, a square coil made up of the 400 turns, n is equals to 400, and the rotated at a 10 hertz of the frequency, and the magnetic flux density is the 0.1 Tesla. How we have to calculate the induced EMF or the output voltage? Same thing, means induced EMF E maximum we have to calculate. So we are going to ignore the sign parameters because sign is maximum at whatever the angle is, but its maximum value is 1. So we are taking, because the question is says that maximum calculation, so we are taking that one as a 1. NBA 2 by F, the value of N is 400, B is 0.1, area is 0.1 multiplied by 0.1. Why I multiplied 0.1 and multiplied by 0.1? This is the question for you, I'm not discussing here. Anyway, 2 pi F, so pi is understood 3.14, F is 10, and it is taken because the frequency is given 10 hertz, 2 from the formula, and after all the multiplication the answer is 25 volts. It means that the induced EMF maximum can produce is 25 volts. So this is the case what we are interested in. Again, welcome back to the previous slide, and in alternating EMF can be produced in a generator or alternator by this method that we are discussing here, and each coil can be connected to the slip rings. So this first coil and second, if we have the more coils, the all coils needs to be connected in the same pattern, that the first end of the coil is connected with the first ring, second is connected with the other ring. This is the connection here that is coming from this side shaft, and the rings are of course rotating, and we need carbon brushes that provide the stationary contact, and as a source of the current we can take from this useful for our applications, and alternator becomes application. As the slip ring rotates with the coil, spring loaded carbon brushes, basically there is a spring which provides a push, and still due to the force towards the inner, this force, it always stays in its position, and it tries to attach all the time due to this force of the spring with the brushes, rotating brushes, and at the end we had connected with the wires, and for our useful purposes for getting the current out of the system. Anyway, AC generator, basically this is the difference. This is the case of the DC, this is the case of the AC system, and here we need two carbon brushes because of the two slip rings, but here two carbon brushes are required again because of the positive negative for completing the circuit, and commutator is used. Commutator is just like a slip rings, but it has here a gap, and the one end of the coil is connected to the half of it, and the other is to the half, and there is always a gap when the coil is rotating. Commutator is rotating, but when this portion comes towards left side, it will behave as a positive, and then this portion will behave as a negative, while when this portion comes towards the other side, suppose this one comes now here, then the negative this one half portion of the commutator which was behaving as a negative here in the first half of the first half cycle, then it is behaving as a positive and it reaches here, while this will be behaving as a negative because there is a disconnection and insulating material is available between them. So there is always, when it comes to this side, whatever either it is this one or this one, it will behave as a positive. When either this one or this one comes towards the right side of the carbon brush, it will behave as a negative. So we are getting the DC current outside, while the brushes behaves where they have no disconnection, they are totally connected here. So it means that they are blind in this case they don't know about the separation. They just provides us the still connection with the output, and the output obtained in this case of alternating is like that. Basically we can also say another thing, that the coil basically produces an like that type, coil is producing like that movement, coil is producing, but it is our commutator that basically when it reaches here it changes the, because it is disconnected from each other, it changes its position in such a way that the commutator rotates past the carbon brushes. The effect is the same, the effect still remains the same. It just behaves like a bridge circuit diode, and applications like a series we are discussed in here, it will behave like a diode here that just allows the current in one direction, same like that case. So it just tries to filter the AC current into, converts into DC current here. So it is the commutator which describes this circuit as a DC generator, while the slip rings is decide that this is an alternator. Basically this is the main difference. We can also use more than one coils, and practical generators basically not only one coil, there are more coils that are wound armature, they're called armature, and they're wounded on a soft iron core so that to capture more and more magnetic flux. So more coils are used definitely if at this stage it is getting the maximum current, but and at time comes when it is also getting the minimum current. So why not we are using the two? When one is getting the minimum current, the other should get the maximum current. The position is such that the one, when one is at this position, at the horizontal position, the other is in the vertical position. Like this is the coil 1 graph, and this is the coil 2 graph. When the overall graph becomes a smooth DC, when we just connect it with the filters like capacitors or just our regulators, we can just get, we can easily get the straight and constant DC power. Okay, this is the alternator picture you can see here, and this alternator is small alternator that is basically called dynamo on the bicycle. It is a driving wheel that is connected with this rotating wheel of the bicycle. When we rotate the bicycle, it is shaft is directly connected with the rotating magnets. When they rotate and cut the magnetic fields and the isolated stator, then definitely current is produced. And this is the small alternator. Coming up, next topic is introduction and induction caused by changing magnetic fields. This is the end of episode 18. Further discussion will be continued with the next topic and interesting topic. Stay tuned, watch and grow.